Hi, welcome back to the Math Studio. We got one more section here where we're going to look at an example that involves forces. So let's get right to it, not that, this. So we have an example where you have a 100-pound weight hanging from two wires, and we want to know the tensions, the amount of force that is, in the two wires. You've probably done something like this in your physics class, so this should be a little bit of a review. But if not, here's how you set this up. What we're going to do is we're going to write each of those tensions in terms of their uh, their magnitudes, so that tension one will be so if you imagine that tension one, the magnitude of tension one is the length of that, it's the amount of tension, the amount of force, then tension one, the vector, will be the magnitude times cosine of 50 degrees, because there's that 50 degrees there, plus the magnitude times the sine of 50 degrees times j. So the x component is 50 degrees, is the magnitude times the cosine of 50, and the y component is the magnitude times the sine of 50. We have a similar situation for the tension 2. You're setting that up the same way with 32 degrees. Now you might wonder about that negative there. The reason for that negative is because back here with my original problem, I had 50 degrees up there in the upper left corner of this diagram, and this translates using the rules of geometry to be 50 degrees in that, you see that little green triangle there next to T1. And so, but T1, even though that's a positive, it's going to give you a positive cosine. The tension one actually goes towards the negative in the x direction. So the x coordinate will be negative on this graph. So that's why I have a negative there. Anyway, here's the deal is I want the sum of those two tensions to equal the weight. So I need the weight. The weight is negative 100j. So that's just 100 pounds pointing straight downwards. So that's why it's negative 100 times vector j. So using that, we can set up this equation. Tension 1 plus tension 2 is equal to negative W, which is 100j. So let's go ahead and work this out. I know this looks really, really crazy, but what I've done here is I've taken the first of these equations, that is the first of which equations? Pause. Okay, so I discovered that I'm missing one slide here. So let's go back and I'll slap this slide in here using my iPad. So here we'll just have to pull this up briefly. I'll make it big in a minute. Can I make it big? Let me try this. Ooh, it's huge. Okay, so but I need everything to be visible for just a few minutes, then I'll make it big. So everything. Didn't I say everything? There it is. Okay. So everything's balancing. And so we have that the x components, that's the I components on the left side of that equation up there. Here, I'll write it here. T1 plus T2 should equal 100j. So the I component on the left should equal the I component on the right. Well, let's write these down. The I component on the left is this. Just a minute, this is going to irritate me. Okay, so I've got it all written here finally. What I have here is, if you think of the I components on the left and right of this, so looking up here, well, wait, there, you can see at the very top, the I component of T1 and the I component of T2 are this and this. Those equal 0. And then on the j components are this and this, and that should equal the j component here. And I don't know why I have a negative there. I'll just get rid of it. So we have those two equations. So what I'm going to do is I'm going to take this first equation and I'm going to solve for, say, T2, I think it is. So take this first equation and solve it for T2. Whoops. So take this and I get T2 is equal to T1 cosine of 50 degrees over cosine of 32 degrees. So all I did there is I moved this stuff over to the right side and divided both sides by cosine 32. Now I'm going to take this and I'm going to substitute it into the second equation for T2. And that's going to give me my something that I can actually solve for T1 and T2. So let's go back to this big, maybe, there we go. Okay, so that's what's missing between these two slides. So you can see there that T1 times cosine of 50 over cosine of 32, which I have put in place of T2. Now I can solve for T1, or magnitude of T1. That's pretty easy. First of all, factor out the T1, and then divide everything by that parenthetical thing. And by the way, sine over cosine of 32 is tangent 32. So there's my magnitude of T1. To get the magnitude of T2, just go back to this expression that I have right here, and you're going to plug T1 into that right there. There we go. And I'm not sure why it's doing that. Okay. Oh yeah, so that's 85.64 pounds. This one is 64.91 pounds. And so we can actually come up with the components for these things by using our original expressions for T1 and T2. Using those two magnitudes, you get these as the expressions, but that really isn't, we don't really care about those. What we really care about are the actual the magnitudes, how much tension there is in each of those lines. Well, you can kind of see from this example and some of the other examples that you need to know your trigonometry. You need to know how to do algebra, because that's all this is. You're doing a bunch of algebra and a bunch of trigonometry. So don't shy away from that stuff. And if you need the extra help, if you need to remediate, let me know and I'll set up something. We'll figure it out. Even though I'm not using Alex, I'll figure out a way to make it happen. All right. I know you've got questions about this stuff. Bring them to class. They'll give us something to do. All right.